Yo, what's up? It's your boy, a J, a O, a S, a H, a A, a B, a R, a A, a H, a M. And we're back. We're back with the 1 hour. Say what? 1 hour of general chemistry. Preparing for the labs. Oh yeah. Oh yeah. Let's let's go. I don't care if it's not optimized. But so should I first dissolving a sample in the 50 ml of water, then the magnesium stick in the hand concentrated in the half concentrated, then on to the solution, burn it to see the color, use the original salt that produced that color from section 7 again to confirm that that was it. Yes, restart time for 30 minutes. What the fuck is that? That's my clothes, I guess.
I see a lot of resemblance with coffee and liquor. Is it just me? Because coffee is bitter, alcohol is bitter. Mmm. Something's going on. Okay. So basically, I use the magnesia stick to figure out the insoluble compound. The carbonate of the water soluble compound. But I'm a bit metal carbonate of the water, but I'm a bit confused on the part where dissolving 50 milliliters of water and the compound
Ayo wasp.
Yo, Dalmatians, what's up? I saw some post about your YouTube channel. You were preparing a series. Interesting. Is it like a story based?
My headphones are broken again.
Okay. You were
So like I can't hear ya. Also that show Remnant.
Remnant, okay.
I made a Discord server.
Mm-hmm.
And now there's over 20 plus people working on it.
That's cool. Mm-hmm. Oh, it's the server for the series. Is the server just for the series or do you
Yes.
just for the series? Oh, okay. I understand.
I'll put
Well,
the link to my server.
oh, okay. That's good. Is it on your channel? Uh, dissolving 50 milliliters of water.
I think, but not RN.
Oh, okay. Oh, yeah. Let me know when it's available on the channel, or you can post the link in crack cord.
It's there.
It's there. Crack cord? I don't think so. On your channel. Mm-hmm. So would the burning process even pick up? Soluble compound as
Can you
it's
show the
been
server if you have it?
dissolved? Very much. What? I think the music is a bit too loud. It's there. Can you show the server if you have it? I'm looking up. Oh yeah, there we go. There's Remnant Discord. What's the meaning though? 21 members, that's cool. Accepting invite. Allow. Mm-hmm. What do you want to do here? I could help in all. Nah, I should not. Character arc, storyboarding, background art, effects, code directing. I can help you with all. Don't take me serious though. Treat everyone with respect. Absolutely no harassment. Yeah.
Just skip if you don't want to work lol.
Nah, it's just I'm gonna just take part in everything. No spam, self promotion, server invites without permission. Yeah. No age restricted, obscene scenes, of course. Mm-hmm. Don't speak anything other than English. Maybe you could change the spelling. Toher. We got voice acting. Oh. Animating general. What's this? Mm-hmm. Okay. Appearance: head square, square mask with no facial features, heart-shaped eyes with X pupils. Okay. And mustache on mask, nose. Okay. So there's 10 voice actors, 2 writers. What's this? Does Roblox count as social? Really? Roblox? Story storyboarding department. SFX music. SFX music. Mm-hmm. Well, it's a step in the right direction. Not gonna lie, this looks cool. Well, well, That's a good start. So, what type? No, I know. I'll ask on the Discord. Animating department. So, so from the looks of it, we are going for a 3D sorta animation. No, it's a 2D show. Okay. I never worked. It's PG-13. It has blood, violence, and a bit of cursing. Animation. I never worked in animation, but hey, I could help. I could try helping. Um, learn. That's a storyboard of the theme song. Hired, hired, hired. Like you paid someone. Hired, hired. Like you paid someone. Oh, there's random. Mm-hmm. Okay, yeah, I should focus on this one just for a bit. Yes, it will work. Flame tests require very small amount of ions, so even if dilute solution usually gives a visible flame color. The key point is that you are not burning the water. When you dip the magnesium stick into the solution, very thin film of solution stick to the surface of the stick. When you put the stick in the flame, water evaporates immediately. Remaining metal salt stays in the stick. The metal ions are excited in the flame, producing characteristic color. Mm-hmm. Why the manual suggests a dilute solution mainly helps because it ensures the sample dissolves completely, avoids large crystals sticking to the stick, allows you to repeat this test several times. Practical workflows for your case: dissolve one spatula tip of the sample in 15 milliliter water, clean the magnesium stick, dip in half concentrated HCl, place in a flame until no color appears, dip the stick into your unknown solution, place it in the flame, or observe the color. Okay. I just got okay. One detail about your carbonate: if the compound you isolated is a metal carbonate, it might dissolve only poorly in pure water. That is why the manual adds the hint: dissolve carbonate in diluted HCl. Ah. Okay, so when you add a little HCl, the carbonate converts to a soluble chloride and releases CO2, making the solution suitable for flame test. If you want, okay. Okay. Organic compound. The different benzoic acid derivatives have all different melting points that can be compared to different literature value. However, some of them. Okay. So I'll end questions for these with one last statement. One last question. Fuck you, Stephanie. I don't give a shit, Stephanie. Just put your stuff in here. As should I dissolve the M carbonate in HCl first, then dissolve in water? Or is there a different approach with dissolving HCl in water, then adding the sep? Okay. After that, start with the identification of organic compound, and from the looks of it, this is a bit hard or have some steps to do. എനിക്ക് വേണ്ടതല്ല, ഞങ്ങൾക്ക് വേണ്ടത്. Oh, what? Dissolving a metal carbonate for the flame test. Do not dissolve it in HCl and then add water. The correct approach is simpler. Take a small spatula to put your carbonate. Try dissolving it in 50 milliliter distilled water. Then, if it does not dissolve well, then add a few drops of HCl directly to the solution. Okay. Makes sense. Ow. 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 Oh, fuck. Okay. Identification of the organic compound. This is actually not complicated as it looks. Okay, bro. Okay, AI. I'm here. It's not actually okay. Measure the melting point of your sample. Make sure the solid is completely dry. Procedure: grind the sample gently. Fill a capillary melting tube with a small amount of sample. What? Where did they mention? Place it in the melting point apparatus. What's a melting point apparatus? What's the capillary melting tube? The fuck is that? But the Illuminati, 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 Ah, that's a different form of melting point apparatus. Okay, so from the one I remember was a plate. So from my last intro lab, I remember glass slide, and the sample was placed on top of it and was checked for MP by observing it using a microscope, and the MP range is measured from the starting of melting to completely melted. What you described a different melting point method, but the principle is the same. In the new introductory lab course, the melting point is measured using microscope hot stage method. Where did it mention that? Where did you mention that, boy? Sample is the same as your reference compound. The melting point range should be same as the melting point of your sample range. Okay. Qualitative analysis of the unknown sample 1. Identify the cation and anion of the unknown sample by methods described above. Follow the procedures described. Part 3. Identification of the organic liquid. Identify an unknown organic liquid. An unknown organic liquid is identified by So this unknown organic liquid, is it given It was after it all, because I don't see that. I didn't see that. Bum, 30 minutes? Okay, that's good. Hey. Oh, whoa, what the fuck was that? Ah, interesting. Okay, there's no such thing as. Okay. Wait. Just gotta move this right. There you go. There you go. That's it. I could make this bigger if I want. Should I though? No, it's gonna. I need up. I need up. Where did they mention this thing? Small amount of solid is placed on the glass slide. The slide is placed on heating stage. The sample is observed through a microscope. Used temperature. Yeah, yeah, yeah. Your current manual mentions capillary tubes. Where? I don't see a capillary tube. Okay, mm, I just saw that it's not just measuring the and separated compounds MP, but also the MP of the reference mixed with the separated organic compound, and that's how it's confirmed. Which comp, which organic acid is it? You're correct about the melting point mixing idea, but the two things need to be separated clearly. Why you did not see the capillary tube mentioned in the text pasted? The manual does not explicitly describe the apparatus, it only explains the principle of mixed melting point test. The line that implies the usual method is prepare and measure a separate mixture for each possible compound. In most labs, this automatically means capillary melting point measurement, but the manual assumes you already know the procedure from the introductory lab course. First off, I did not do this capillary melting point measurement. I haven't done that, okay? I don't know how that works, but yeah, I could give it a shot. I could give it a shot. You know what I'm saying? I could give it a, give it a, I could give it a, give it a shot. Why you did not see a capillary tube mentioned? The text pasted at that point. The melting point of your unknown sample. First measure the melting point of the pure separated organic solid. I should keep on track with the time because this should be 1 hour. 1 hour. 40 minutes. So we got 20 more minutes. I just set a timer for 20 minutes. What 20 minutes? From the list of benzoic acid derivatives provided in the lab manual, choose the two literature melting points closest to your value. If you choose A and B, mix to melting point. Sample plus reference A, measure melting point. Then grind sample plus reference B, measure melting range. Interpretation. Melting range stays the same. Compounds are identical. Oh, yeah, that makes sense. Okay, that makes sense. If the melting point range is broad, then the samples are less likely to be similar. Conclusion, sample plus melting point. Important thing many students misunderstand. You do not measure the melting point of every reference compound individually. You measure your sample. That is all. The organic liquid section is completely different. Yeah, I was wondering, organic liquid? What sort of section was that? Okay, I get that part. I get for the organic liquid, I kind of understood that. But the unknown organic liquid, I believe they give it to us, right? They should let us. Let me check if they gave us. Okay, I get it. I see it. But what's with the sample section 10 part 2? Okay, I kinda understood. The figuring out which organic acid did we separate part, but now my next question is for the section 10 part 2. So I just realized that yes, we are given this unknown sample, this samples section, but how do I proceed? Should I do the same as section 1 on separating the three component mixture, or is this sample something else? Oh, come on, just get over the ads though. Why would you gotta do these ads, YouTube? It's a known sample. It's completely different sample from the mixture in section 1. You do not repeat. New unknown salt, qualitative ion analysis. Okay. Separation plus density plus melting point. New unknown salt. Qualitative ion analysis. Unknown organic salt. Liquid. I want to test one thing. Just a minute. Is it? Oh yeah, the camera works. Okay. Oh. Does that make a difference though? I don't think so. Oh yeah, maybe. Maybe a little bit. Nope. The desk view is still bad. What kind of stupid songs are these, bro? Oh, that's a good one. That's a good one. Prepare a dilute solution. Take a spatula tip of the unknown salt. Dissolve it in about 50 milliliter distilled water. A lot of 50 milliliter distilled water coming up. It's not what. The reason for dilution is that silver precipitation test works best at low concentration. Identify the cations. The first and fastest test is the flame test. So one spatula tip dissolved in 50 milliliter water can be seen as guideline. Okay, okay. A lot of the porcelain plate is involved a lot. Is involved a lot. Mm-hmm. And I was planning to do section 10 at the last because that's how I planned it. So now after, so it, I can get it. So we're talking about section 7, flame test. Okay, okay. Okay, flame test again. The magnesia stick. Again?
Again.
Okay, I don't care. If the dip magnesia stick in HCl, dip your unknown solution, put it in flame, observe color. You must run reference test, blank test. What do you example test result unknown green reference barium green blank none. Oh, just to make sure. Okay, okay. So the blank test is done at the end or at the start? I feel like the blank test should be done at the start. Identify the anion. Oh, that's where the anion. Okay, okay, okay. So this is a single, some sort of, yeah, it's a salt, right? It's not a three-component system. It's a single component system. It's a salt. So the salt has both anion and the cation. We figured out the anion using section 7 flame test, and the figuring out anion is using silver. Now you test the same solution for the anion, AgNO3 solution, possible anions. Yeah. Confirm using acid test. Observation helps confirm the anion. Example. Why is not the adding acid mentioned here? No, I think it's part of section. Which one was it? 5.2. Right, final salt. AgCl stays, AgBr mostly stays, AgI stays. What? Important thing, you do not repeat section 1 separation. Okay, okay, well, okay. You don't have to rub it in. I thought we have to do it. Okay, you don't have to rub it in. Identification of the organic salt. Okay, okay. Okay. I kinda get this one too. Now for the last identification of the organic liquid. Also, I'm wondering which part of section 10 are they referencing here? Or is it just oh, just overall? That instruction refers to the entire section 10. Okay. That's all I need to know. How about the identification? Simplest experiment: place a few drops of the unknown liquid in the refractometer prism, measure the refractive index, record the temperature, compare your value. Record the temperature. When did temperature... Record the temperature. I'm a bit confused on that. Compare your value with literature values. The organic liquid can be one of the following. If your measurement is... okay, the temperature, I feel like it's gonna be the same. Okay, the temp, I feel like it's gonna be the same unless it's an alcohol that evaporates, decreasing, but usually the temp should stay the same, and it's not a good deciding factor. Very important, but not the reason you mentioned. It's not mainly about evaporation cooling. The reason is refractive index depends on the density. Density changes with temperature. Even a 1 degree difference can change the refractive index by about... okay, that may look small, but in your list, many liquids differ by, so the temperature can definitely change the identification. So, Anyway, for checking of your analysis, you don't need to identify the organic solvent yet. You have to in the protocol of the course. We will check if the measured value is reasonable. Reasonable, okay. Be aware that the refractive index in the literature can sometimes be measured in different temperatures, so make sure you measure your sample at the same temperature as your literature value. Ain't gonna lie, where do I get the literature value? Wow, that's a long time. Okay, so I have a general idea on so from so wait. It's 1 hour. Section 3, Section 7, Section 5.2, Section 10. Okay. So from the looks of it, the order of doing things will be Section 3, fermentation setup. Section 7, Section 5.2, then ten point two, then 10.1 and 10.3. Where is it? These two, if I get enough time. Section 10.1 should not come after 10.2. Section 10.1 is tied to Section 1 because it analyzes the three component mixture you already separated earlier. Yeah, that's what I wrote, right? Section 10.2. Should not come after. Yeah, but it's not related, right? Okay. Think. Silver salt experiment. This takes longer because you wait. Wait. This section defends correctly, though, so your order is correct. Yeah. So, like I said, if I unfortunately wasn't able to do section 10.1 and 10.3, I can do it another day because it's not related to others. Like the half cost, like the involvement of half diluted involvement of half diluted HCO, the magnesium stick. Wait, this is involved in section 10.1, I guess. The AGCO some things are from earlier. Oh, earlier. What did I say earlier? Bro, the tongue is not tonguing right now. Earlier. So yes, have consider again, but they're standard equipment and do not require earlier experiments to be done the same day. Thermometer, okay. Should stay when you plan. The flame test, precipitation test. So doing these before 10.2 is correct approach. Okay, can you let me know what are the common things required between section 10.1 and the section 7 and section 5.2? What is this? It's the same flame test. Oh, have considered ATL, Bernson burner, reference salt, confirm flame color. Okay, okay. So from the looks, so from the looks of it, section 10.2 and section 10.1 could be done or should be done. I could do it. Come on. If I want, I could do it. Okay, I'm gonna end the stream. We're gonna continue with emails. Peace out, YouTube. Twitch is gonna keep on running.